Hello everyone. Today we'll see about Session 3 from Unit 1 for Data Communication Network for 5th Sem BCA. So in this session we'll see the evolution of the network architecture and the services. So in this session students understand the network architecture and students know about the telegraph networks and the key elements of the network architecture. So first, what are the evolution of the network architecture and the solution? So a communication network is a set of equipments and facilities that provides a service like the transfer of information between users located at various geographical points. The most familiar example of communication network is telephone network, that is telegraph or telegraph, television broadcast network, cellular network, and the internet. These are the examples of the communication network. The different communication network differ in the detail of how and in what form information is transferred, how the information is transferred in different network, that we'll see. And there is a tremendous improvement in transmission bit, that is data rate, over the last 150 years. In this time, we have developed from telegraph system that operated on tens of bits or seconds to modern optical system that operate terabytes or seconds. Next topic is telegraph networks and message switching. In this method, the text was encoded into sequence of dots and dashes called Morse code. Whatever the data or the text that we send, that will be encoded into number of dots and dashes that will be called as a Morse code. Each dot or dash communicated by transmitting short and long pulses of electric current over a copper wire. And in this network, a message or telegram would arrive at a telegraph station and an operator would make a routing decision based on the destination address. The operator would store the message until the desired communication line became available and then would forward the message to next appropriate station. The store and forward process would repeat at each intermediate state until the message arrived at the destination, until the message reaches the destination state. So the forward and store and forward process will be keep on repeating at the intermediate stages. So this technique will be called as message switching. And the transmission rate at which information would be transmitted over telegraph circuit was initially limited to the rate at which a single human operator could enter a sequence of symbols. Next topic is key elements of telegraph network architecture. So in these key elements of telegraph network architecture, we'll come across digital transmission, framing, multiplexing, message switching. So in this first one, digital transmission, text messages were converted into symbols, dots and dashes in case of Morse code, or 0 1 in case of baud code or ASCII code. Transmission system designed to convey these symbols. Framing. Next one is framing, a method for taking the sequence of dots and or dashes or zeros ones and grouping them into characters. So whatever the text is that is encoded, that will be grouped into characters in turn meaningful messages. So the next key element is multiplexing, a system for combining symbol from several operators and sending on to the same communication line. Next one, message switching. Message contains source and destination addresses. They are forwarded hop and hop across network. These are the key elements of telegraph network architecture. Next one, elements of packet switching architecture. High-speed digital transmission link to transfer stream of binary information. Next, digital destinations are identified by a unique address. Messages are segmented into packets at the beginning of the network and then transmitted. At destination, packets are reassembled to recover the original message. First, the messages will be transmitted in high speed transmission, and the destination will identify the unique address, and whatever the messages sends at the beginning, that will be transmitted in the destination, that will be reassembled to the original to recover the original message. Packets between adjacent switches are transmitted inside the frames. The frames could contain that the frames may be contain error detection and correction methods. Each router maintains a routing table that are dynamically calculated in response to change in network traffic and topology. The flow control methods between host computer prevents buffer overflow. Applications that rely on the transfer of messages between the computers are developed. So these are the elements of packet switching architecture. So essential elements of network architecture are digital transmission line, medium access control line, routing table or dynamic of routing table, congestion control, internetworking, segmentation and reassembly, end-to-end error recovery, variety of applications. So these are the essential elements of the network architecture. In the digital transmission line for transfer of binary information between communication parties, so the exchange of the frames between the adjacent nodes as well as the check bits for error control. In the medium access control the protocols to regulate data transmission in shared broadcast medium and the exchange of packets between switches in a network. A routing table and dynamic calculations of routing table in packet switches to determine the path. Congestion control mechanism in the network. Internet working provides connectivity across multiple dissimilar networks, segmentation and reassembly of message into packets, last end-to-end error recovery mechanism to ensure reliable transfer of data, and the final, the variety of application to support the end users. So these are the essential elements of network architecture. So in this session we have come across the evolution of the network architecture and services, telegraph networks and message switching, key elements of telegraph network architecture, elements of packet switching architecture, essential elements of network architecture. So these are the references. Thank you.